If you're starting to feel the holiday stress, I have got the answer for you. So our Rest and Relax oil by Radical Roots is hands down our bestseller, and it is so for good reason. This formula is so safe, effective, and versatile. Everybody loves it. So what we did is we combined full spectrum, high quality hemp with a Chinese herbal formula that nourishes the heart and calms the spirit. So it's great to take during the day if you're feeling any sort of anxiety or stress, but it's also awesome to take at night if you're looking to make sure that you're getting the highest quality sleep that you can. I take it almost every day, and I'm certainly taking it any time that I'm recording a podcast. Head to radicalrootsherbs.com, use the code HOLIDAY30 and get 30% off of our Rest and Relax tincture through New Year's. Hey guys, it's Dr. Chloe, and you're listening to the Radical Remedy Podcast. Today's guest is none other than Dr. Robert Melillo. So he is the founder of the Brain Balance Program. He is an internationally known chiropractic neurologist, professor, researcher, and expert in neuroscience, neurology, neuropsychology, and rehabilitation. So Dr. Melillo's system of working with the brain is truly unique and incredibly fascinating and effective. I find it really interesting to see the potential not only for children with neurological disorders, but also for adults who are dealing with neurological quirks that we're starting to learn about later in life. Please check out this episode. I think you guys are going to find it as interesting as I did. Let me know what you think, and check out his books. He has the Disconnected Kids book line, and it's really, really phenomenal. Again, it was such an honor to speak with him, and it's an honor to have you sharing this conversation with us. All right. Welcome, everybody. This is Chloe here, and I'm here with Dr. Rob Melillo. He is the founder of the Brain Balance Program and the author of multiple books, which are really awesome. Some of them I read at the beginning of me and Remy's journey. And we're really honored to have you here. Welcome, Rob.
Well, thank you for having me. It was great, and it was such a pleasure to meet you and Remy the other day.
Yeah, no, it was really fun. So tell us a little bit about how you got into this field.
Well, I got into it as a parent, just like you, basically, meaning that, my interest clinically was always neurology and rehabilitation. That's kind of how I started my journey. I started out really as a chiropractor, really interested in working with athletes, and because, that was my background, and I had had really good experiences with that. When I was in chiropractic school, I got exposed to the fact that chiropractic is really based in neurology. And I really, got into that. And then after I graduated, I got my diplomate subspecialty in neurology and then also in rehabilitation. And I just, wanted to focus my career on looking at merging neurology and rehab. And I started getting into academics, and I started doing research and teaching, and was pretty successful in that by the time the early mid-90s. And then 1995, I walk in my house, and there's a woman sitting at the kitchen table with my wife, and she's crying. And I'm walking in late, as a lot of us practitioners do. And it's 9:00 at night. I have 3 small children. And she says, Rob, this is Denise. Her son has severe ADHD and mild autism, and she doesn't know what to do. And in my office, I had started one of the first multi-specialty practices in the country. I had acupuncture, Chinese medicine, nutrition. I had MDs, PTs, OTs. I had psychologists. I had all of it in my actual office. And so she knew that I knew a lot about a lot of different things, and especially a lot of different non-mainstream, alternative approaches. And she had only tried really medication and some basic behavioral intervention. And she was kind of at her wit's end. And so I grabbed my wife aside and I said, I see what you're doing. This is great, but I already don't have any time. I'm not home. And, so I don't know what ADHD is. I don't know what autism is. And she says, well, this woman's in pain. She needs help. And I have this feeling that you are meant to do this. Like, you can help her. I know you can.
It's definitely a calling.
Yeah. And I said to her, well, okay, and I just kind of couldn't deny my wife. And so I talked to Denise and went off. And then 2 days later, I go into my son's parent-teacher meeting. He's about 6 years old. He's in first grade. Sit down and teacher says to me, don't know how to tell you guys this, but I think your son has ADHD or something like that. And so now I'm hit twice in a matter of 2 days with this, right? And first I feel like, I'm embarrassed. I'm embarrassed as this professional who's out there teaching neurology, and I don't even know what it is. And then I feel like most parents do, I feel like I'm to blame somehow for my child's issue. And how did I not see this? And as a professional, I feel even more responsible, right? But at the same time, I hear my wife saying she had this feeling that this was meant to be. And I'm getting these two things and I'm saying, this isn't a coincidence. And so I just say, all I know at that point is I'm going to try to help my son, and I'm going to try to help Denise's son. And that's how it started. And, the first question for me was, really neurologically, what is ADHD? What is autism? What is happening in the brain? And I went to all the people around me that I thought would know, and they all came back with the same answer. They had no idea. So that started me on my journey, was first and foremost, because I knew I couldn't even know if I could help my son until I really knew what it was. But I knew a lot about the brain. I knew a lot about neurology, and I had already been doing research. So, I had the tools. And so I just dove into it and spent the next, as long as I could, really figuring out what that problem was.
Yeah. And you've started such an incredible program that's helped so many, thousands and thousands of children and families. It's really incredible. So the book Disconnected Kids was one of the first books that I read when I was starting my journey with Remy. Remy wasn't diagnosed till he was 2.5, though obviously very, very delayed. And so I found it was a really interesting program where you're looking at the different hemispheres and how they're communicating. Do you want to dive into a little bit of that and how that sort of works and how that affects children?
Sure. Well, that was, as I started really diving into the research and spending every spare moment I had really in medical school libraries and copying papers and getting books and staying up till, 2 or 3 in the morning when everybody was sleeping so that I could kind of have some time to read and write. In the, mid 90s, it was an interesting time because that was declared the decade of the brain by Bill Clinton. And so all of this new brain research came out, and also new ways of imaging the brain in real time that had never really existed before. So all this information about how the brain actually functions. Before that, the only way you could really get an idea of what was happening in the brain was after somebody died. You could look at an autopsy of their brain, but, looking at a brain in real time was not something that was really very feasible. So, all this brain imaging came out, and it started the concept of functional connectivity really started to become in the forefront, meaning that how the brain communicates, that it was becoming pretty apparent that most issues that are neurological, whether children or adults, are really not structural. They're not chemical. They're not necessarily genetic mutations, but there's just something about the way the brain is communicating and connecting, and the way networks communicate and connect, that really are the foundational problem. That's the issue. And so, I was fascinated by this, and it made a lot of sense to me. And so the problem really is that different networks in the brain aren't really communicating, and especially between the two hemispheres. And the two hemispheres, how they mature and how they develop. So that was really important, because the problem was about this functional connectivity where areas of the brain weren't communicating, but it wasn't clear as to how that happened. And then later on, I was able to understand and figure out that it really was a product of improper development and growth. So now in psychology and psychiatry and mental health and education, we realize that almost everything in adults really starts in childhood, that it's all developmental. Either in the womb, in the first, 3 to 6 years of life, something goes awry. And so I was able to figure out that, what happens is that during the growth early on, that there's this kind of developmental imbalance where certain areas, certain networks on one side of the brain are slowed in their development because environmental factors are basically inhibiting the expression of genes. And the right brain develops first in the womb and for the first 2 to 3 years of life. So when that happens, the right brain slows down, and then the left brain tends to speed up. And if there are, and especially in people that are gifted in their left brain skills, this kind of creates this developmental imbalance where we have areas of the brain that are actually overactive and maybe even hyperactive, and you have other areas that are underdeveloped and immature. And once this is in place, it stays that way. And depending on whether the delay is in networks on the right side and overactivity on the left or vice versa, you have completely different types of presentation. So like ADHD, what you have is, attention deficit hyperactive disorder. The attention deficit is the delay of development and immaturity on the right side of the brain, where there's certain networks, especially a network called the dorsal attention network, is underdeveloped and immature. And then you get overactivity of networks on the left side of the brain that are related to motor activity and motivation and emotions and thoughts. So you get hyperactivity of the left brain, or even obsessive or compulsive or hypermotor activity. So you can get tics. And so the combination of the two is what we call ADHD. Dyslexia and learning disabilities typically are the opposite, where we have an overactivity on the right side and under on the left. And the makeup of it, all the different networks, all the different areas of the brain, it's unique to each person. So no person has the same combinations of hyperactivity and underactivity, but the bottom line, the problem is the same. And this is the core issue now. And in understanding that, and coming to that, and I wrote a textbook in 2004 called Neurobehavioral Disorders from an evolutionary perspective, Neurobehavioral Disorders of Childhood from an evolutionary perspective, where I really, put this down. It took me about 10 years to really compile all of this, but that book is used in graduate programs, medical schools, psychology programs, and now that that understanding is really at the highest level of research. Really what we understand is happening with these issues. And once you understand that, then it opens the door and says, okay, now what can you do to try to help or even fix these issues?
Well, yeah, definitely. I actually have that textbook in my Amazon cart at the moment. I was debating whether to do that or to just jump in and try one of your courses. But I've loved reading the work that you've done, and it was really cool meeting you and seeing how you assess children also with working with Remy this past week. So tell us, let's go into sort of how you figure out the imbalances and then where you take it from there.
Sure. So, I do, as you said, I have a clinical course. I've been teaching to doctors and therapists and teachers for over 20 years, since 2000. And so, it's really looking at my exam and how I train people to do it. It's understanding that whether you're looking at kids or adults, what I do is really what I call developmental functional neurology, which means that, we work with adults and I train people that work with adults. And it's, understanding that all of us have brains that developed as children. And if those brains didn't develop in an optimal way, it may not be affecting us obviously, or we may even be extremely talented or competent at certain issues, because people that are extremely talented are even more likely to develop an imbalance on the other side, that it's all developmental. And so looking at a developmental exam, so whether an adult walks in complaining of adult types issues, everything in psychology now is looking at developmental and realizing that it all starts early on. And so
it's a little daunting as a parent.
Yeah, exactly. But, the good news is that it can all be changed at any point in someone's life for the most part. And of course, you have Remy who has some, there aren't that many percentage of people that have true genetic disorders. It's a bit more challenging, but most issues are not genetic mutations or brain injury. They're these functional imbalances. But even in genetic disorders, you can have functional imbalances superimposed that you can make a really big difference. So, I'm always teaching people how to look at anybody from a developmental perspective to really go back in time and say, did this adult's brain develop the way it was supposed to? And the way to do that is to go back and look at, first and foremost, at what we call primitive reflexes. Primitive reflexes, when a child's born, there's only about 25% of their brain there. And, by the first 3 years, it grows to 90% of the adult size. So there's a lot of growth that's happening. And most of that growth, again, is this functional connectivity in the brain. We're not creating more cells or anything. But when the child is born, they're bombarded with all of these stimuli. But the main thing that causes the brain to grow is movement. Motor activity is the single most important thing in a child to stimulate growth of their brain. It engages their muscles and it engages their senses and creates this massive feedback into the brain, which turns on genes, which then starts to build connections in the brain. And the more the child moves, the more they move in a sophisticated way, the more feedback we get. And then, when we're first starting out, the child really doesn't have a brain. They really don't have a motor cortex yet. So we're born with these reflexes that start in our brainstem at different levels of the brainstem that allow us to do things like the rooting and sucking reflex, which allows a child to latch on and feed themselves. Grasping reflexes, which allow them to protect themselves from hold on and falling and grab things. The orienting reflexes, the writing reflexes, labyrinthine vestibular reflexes, the asymmetric and symmetric tonic neck reflex that eventually lead the child to roll over and then crawl on their belly and then on all fours and eventually walk. We believe many of these reflexes are there to help the child birth themselves. So like the asymmetric tonic neck reflex, when they turn their head, it literally causes them to twist, like they twist out of the birth canal.
It's just a funny personal note. Remy was 2 weeks late. We ended up being induced. We had 72 hours of labor, but he just was not going anywhere. And then we ended up with a C-section. And in hindsight, I really think a lot, the labor never progressed because he didn't have any reflexes. So he wasn't moving anywhere.
Exactly. And, we know that going through, it's kind of like caterpillar coming out of the chrysalis to be able to turn into a butterfly, right? Coming through that birth canal is a similar thing to a baby, that there's this massive feedback and stimulation, and there's, all this good bacteria from that the baby gets that coats their gut and their stomach lining. So these reflexes are really important, and they really help the child to move and engage their senses. They should all be gone by the first year, which then should be replaced by walking. Children should walk at 12 months. 11 to 13 months is what I consider normal. Anything beyond that or before that is abnormal. And it shows that already there's some sort of, non-optimal way of the brain developing. Children need to crawl. They need to crawl in the right way. If they scoot on their butt or if they roll or if they, drag one leg, it shows that these reflexes are getting stuck. The fact that, we have these reflexes and they're there and they help us to move and interact, and then they should go away. And if a child doesn't crawl, or if they have asymmetric primitive reflexes, if they go away on one side and not the other, they create this imbalance of muscle tone. And an imbalance of muscle tone and these persistent reflexes that don't go away is what ultimately produces this developmental imbalance in the brain. And that is what leads to almost every major issue that we see, and it will last a lifetime. So I just used this analogy on Instagram the other day that, when you're getting a child to ride a bike, let's say, they may have training wheels on their bike. And what would happen if you never took the training wheels off and they always relied on these training wheels? they probably never would learn how to ride independently. They couldn't be able to do really sophisticated tricks. They couldn't ride real fast. And, these training wheels would always hold them back. And that's basically, primitive reflexes are essentially training wheels for the brain to help the brain develop until we can take those training wheels off, and then the brain can really grow and soar and become really complex. And what we see is that if they don't go away in that first year, they never really go away on their own. I mean, I can show you videos after videos of adults with full-blown infantile level primitive reflexes in really, really bright, competent people, but who also have struggled their whole life with certain issues. And we can get rid of those reflexes pretty quickly usually. And when we do, it's life-changing. I mean, literally life-changing. Right in front of you, you can see these people like anxiety they've had their whole life goes away. They've had chronic digestive issues their whole life and they go away. Or all of a sudden now they can read where they've never been able to read. I mean, it's really pretty amazing stuff.
It's crazy. I thought it was interesting also. My dad had heart surgery a couple years ago, and ever since his startle reflexes come back, and I'm always like, can we work on that for you? And my parents just think I'm a little crazy. But it's pretty profound. So that happens too also sometimes if there's like an injury or if there's surgery. Have you seen that happen?
Yeah, absolutely. Well, it's actually, there's a name for it. It's called frontal release signs. So what happens is ultimately, with this feedback from muscles and again, going up the brainstem and looking at the brain builds from the outside in and then from the bottom up. And then as it builds up from the bottom up, going from the medulla to the pons to the mesencephalon, midbrain, then to the limbic system, and then to the brain. And then ultimately in the back, we get something called the temporal parietal occipital area, which is the major association area for sensory integration. And then in the front, we get the most impressive association area called the prefrontal cortex, which controls all human behavior and function. And it literally grows out of the motor cortex. I mean, that's literally where it grows from. So if anything affects motor development in any way, it is going to affect the development of our prefrontal cortex. And therefore, it will affect our ability to think and behave. I'm going in 2 weeks, I'm going to be lecturing. This is the third year in a row. I'm the keynote speaker at a conference called Movement and Cognition. 2 years ago, it was at Oxford. Last year, it was at Harvard Medical School. This year, it's in Tel Aviv. And this is some of the top researchers in the world. Over 3 or 4 days, they'll present about 400 or 500 papers and experiments, really showing that cognitive development emerges from movement, from motor activity, from motor development. And so, primitive reflexes is where that movement really all starts. But then ultimately the frontal lobe comes down and inhibits all these reflexes. So once the brain builds from the bottom up, it then comes from the top down like a puppet master and controls everything. The brain controls everything, not just motor activity, but how we process sensory information, how we regulate our immune system, our digestive system, our autonomic system, our hormones, our detoxification system. All of that is regulated by the brain. And this is what most physicians have no idea, that they think the immune system, the hormone system, the digestive system operate independent of the brain. And they can, but for them to operate optimally and properly, they need the brain to do that. And the right and left hemisphere control all of those systems differently. So if there's an imbalance in the brain, we don't get appropriate top-down regulation. And that also includes the primitive reflexes. So if anything affects the frontal lobe in the brain, either a brain injury, a concussion, or neurodegeneration, or Alzheimer's, or dementia, or if they're really sick, like you said, then the frontal lobe can lose its inhibitory control, and these reflexes sometimes can come back. And in fact, that's what we see. I mean, there's a classic reflex called the Babinski reflex that I think most clinicians know of that is called an upper motor neuron lesion sign. So when someone has injury to the brain, the cortical spinal tract, or the spinal cord, we see the Babinski sign. What most people don't realize is that is a primitive reflex that goes away exactly at 1 year, which allows the child then to walk. And when it comes back, it means that, we've lost that control from the frontal lobe.
Yeah, that one's super interesting. That's the one where you do along the bottom of the foot and then the toes sort of splay out, right?
Yes, exactly. And you can see, like on Remy, we saw that it was more on one side than the other, right? So you can see in children that should go away at 12 months. If it doesn't, which often we see, then usually this delays walking, but it also shows that their brain hasn't matured. And that may persist into adulthood. If it happens on one side and then not the other, that means that there's an asymmetry of development where one side of the brain or one side of the brainstem is maturing at a faster rate than the other. And this is representative of this developmental imbalance, which I believe, and my research has shown, is really the core issue in almost all neurobehavioral, mental health, and education issues, and many health issues. Because like I said, when the brain is out of balance, it affects every system. So that's why kids with autism or ADHD, or they don't just have, attention problems or social problems. They also have digestive problems and food sensitivities and chronic inflammation and eczema and autoimmune issues and asthma, and hormone imbalances and all of those things, digestive enzyme problems, because
thyroid issues.
Right, because the brain isn't regulating it.
Well, it's interesting with Remy. So Remy's disorder is mutation in the syntax binding protein. So it's basically how neurons communicate. So when you look at Remy and everything in his body, everything's essentially perfect, especially, he's just very good looking. I'm totally biased. But he's, but it's funny because everybody, it is sort of challenging having a child who's pretty severely disabled who actually looks really neurotypical. I get really obnoxious comments all the time, like, "Oh, he's so big, he should be pushing you in that chair." Oh, and I'm like, "Hey, thanks, haha, you can't walk." But with Remy, like, everything has developed well, but it's his neurons can't communicate, so everything in his entire body is affected by that. So it's interesting to watch, and it's interesting also for me as a practitioner. It's been interesting to watch development in uber slow motion.
Right.
So Remy continues to move forward, but it's very, very slow. So it's given me the opportunity to look into all of these things, and reflexes are definitely a huge part of it. So once you sort of look at these kids and check which reflexes are active and which are more active on which side, then sort of what's the next step for that?
So, again, taking people through a developmental perspective at any age, going back in time and basically looking at them and doing I look at, muscle tone and asymmetry. So people come in and, with infants, the first thing you look at neurologically is their tone and symmetry. They should be balanced. They should have perfect, balanced tone and symmetry at the right level. And you can see that in adults too. So you look at things like, do they have a head tilt? Is there a facial asymmetry, which is really very important? Is one eye bigger than the other? Is the crease between their nose and their mouth, is it deeper, much deeper on one side than the other? Does their mouth droop down on one side? And then I look at their arms and their legs and see if they have, like bending and angulations, or do they have a body tilt? And these can be very subtle or they can be very dramatic, but most people don't even know that they have them. And then looking at primitive reflexes, which may be the source of a lot of this imbalance, and then looking at their overall core stability. A lot of people and adults that have chronic back pain, it's because they never developed a proper balance of muscles in front and back or right to left. And this, imbalance of tone, or their brain being unbalanced, is creating different tone. And this ultimately leads to things like neck pain or dizziness or headaches or back pain. But it really, may go back to their childhood. So we look at core stability, and then part of that. So as a child develops, the first thing they do, obviously, is they roll over, and then they start to crawl, and then they stand up. And, to do that, they have to get rid of the reflexes and have proper postural stability. As they stand up, now they engage their vestibular system, their inner ear. And the first part, there's two parts of the inner ear. One is called the otoliths, which really help to balance the head on the body. So if we see body tilts and head tilts, that usually means there's an imbalance in the otoliths. Then we develop the semicircular canals, which helps to regulate what's called the vestibular ocular reflex, which helps to control and stabilize the eyes in the head, so that when we move our head, our eyes aren't, and we're walking and our head does a figure eight movement, our eyes aren't bouncing up and down, so the whole world doesn't look like it's bouncing up and down. When we move, our eyes stay steady. And this is something that is a developmental reflex. And if it doesn't develop appropriately, then, we see that. And then we go into the eyes and look at the eyes and how we're able to regulate our vision and our movement of our eyes. And then we start looking at how we, are able to perceive sensory information like sound and light and smell. I mean, a lot of the kids I work with have completely abnormal sense of smell. Many kids with autism don't even know how to sniff. So that area of the brain that is associated with smell is hugely important. It's the basis of social development. I mean, animals socialize through smell, right? So the basis of a lot of our social networks in our brain start with smell. This is also why most kids that have these issues are incredibly picky eaters. It's really because they have abnormal smell and taste. So looking at sensory and then looking at sensory processing. So how do we process auditory information and high-level visual information? And then how do we integrate that together? And then looking at, obviously, high-level motor activity, and then ultimately looking at the prefrontal cortex and how we regulate attention and thinking, how we regulate social behavior, how we regulate high-level complex movement, how we regulate eye movements, how we regulate our emotions and motivation levels. And all of those things are ultimately what create human behavior, learning, and all of the high-level functions that we do. So we need to look at it literally in that way. And that's how I do my exam. That's how I train people to look at an exam. And that's how I look at anybody, no matter what age they're at. And usually what we're able to find is that somewhere along that way, that didn't happen. And when we do, we need to go back to that stage and then work with them, whether it's doing specific exercises to get rid of primitive reflexes. But what I've overall found is that all of it, ultimately, we have to create balance between the two hemispheres and between these networks. That's ultimately what we need to do. And if we do that, and as we're doing that, we get rid of primitive reflexes much faster. We create core stability and balanced tone. We create, more appropriate balance between the inner ear and the eyes, so that all of this really, when we're doing that. So, initially with most families and most kids, we start with getting rid of the primitive reflexes, building up their core stability, and then stimulating one side of the brain exclusively to start to create this balance. And then from there, as we start getting changes, then there are more and more complex things we do till we ultimately really get their brain to where it was supposed to be all along.
Yeah, no, it's so cool. Well, it's two things to touch on. One, I think it's interesting, and I'm curious to hear what you think. So one thing that I've always sort of felt, which some people agree with me and some people don't. So obviously, this is to Remy again, but Remy is significantly disabled. He's not walking. And so I've been pushed so much by a lot of his therapists to put him in a gait trainer or a stander or things to try and force him to walk. But to me, I've always sort of been like, let's work on him crawling. Let's work on him, working on the reflexes. Because my instinct was, and what I've worked with some other practitioners, once he starts walking, if he hasn't integrated his vestibular system and some of these other things, then he's just gonna hurt himself and fall down all the time.
Absolutely correct. Absolutely correct. And that's true I'm just working with this man right now. He's an American hero. He was a Navy SEAL. And when he was home from deployment, he got into a severe car accident and suffered severe brain injury. And his wife is just this amazing person that is a Pilates instructor that has dedicated her life to trying to help him. And, he really wasn't getting much help. And, one of my colleagues, one of my students went and worked with him and made a huge difference in their life. But then they asked if I would be willing to go down and work with him. So I was, honored to go down there. And, they had these parallel bars, walking bars, and they were kind of forcing him to try to walk on these bars where she was like literally holding him up with a strap, right? And the first thing I looked at it, I said, he doesn't have any basic core stability. So with people with brain injury, like all of his primitive reflexes are back, right? He speaks like a child. He, understands things in a very limited way. He's essentially gone back to being a child. And so what we need to do is what I said to her was we need to go back and really start working on the floor and on crawling and on core stability. And she got that because she's a Pilates instructor. So she started doing that. And within a couple of weeks, literally, he was able to stand by his bed independently for the first time. All of a sudden, he's also starting to now not need a catheter to pee because now his pelvic wall is coming back, right? And he's starting to actually know when he has to pee, which he had no idea before. And along with that, higher level language but the idea is exactly what you're saying. I said to her, Laura, we can't get him up walking until he's actually stable on the ground. Children don't just go from, rolling on their belly and then stand up and walk. They gotta crawl. They gotta build those systems first. If you don't have that foundation,
of course,
and the goal is obviously to get him to walk independently. And I believe we will. But again, what happens after a baby walks? Then they start to talk, right? Really. So, the high level cognitive issues like talking and thinking and all the things that we want to get back for him is not going to happen until we go back in time and build him back up. And it's exactly with Remy. You're exactly right. Getting a child, I hate the fact that when they throw braces on their legs and do that, rather than really work on, and they don't realize that the reason why the child isn't walking appropriately doing is because they have these primitive reflexes. They don't have core stability. And, no one looks at these reflexes, even though they're part of a normal pediatric neurology exam and have been for decades. Pediatricians never look at them. Almost nobody ever looks at them. And they are so key and foundational in everybody, not just kids, as I said, but adults. And when you get rid of them, you have to be able to build them back up. And I totally agree with you, Remy. We have to get rid of his primitive reflexes. We have to build his core stability. We have to build him on the ground where he's stable and he can, be on all fours and sit up and be good. And then naturally he'll start getting up and walking and be able to walk in a more stable way. And so, getting him up and getting him in a trainer or a walker is absolutely the wrong thing to do. And you're right.
It blows my mind that it feels like all of this is so logical and makes so much sense. There are so many people who are doing this and doing remarkable things and making life, huge changes in people's lives with neurological conditions. Yet it seems like most of the therapists in this country, at least that I've met, really don't know any of this at all. So I'm so happy that you have a training program, training other practitioners, because it's so important.
Remember, I said from the very beginning that most of the time the parents know more than the people that are actually out there doing it. And it's not that the, professionals aren't, bright and intelligent and dedicated. They are. It's not, it's not that they're doing this and not aware of this because, they're lazy. It's because what happens is that very few people actually really understand the brain. I mean, even what people don't realize is most neurologists, most psychologists, most psychiatrists, they really don't know a really high level, at the high level, the way the brain really functions. They know clinically how to be able to assess and treat issues, but they really don't know how it works and they really don't know how it develops. And they don't understand how it doesn't develop. And the average pediatrician knows nothing about neurology. And so, the idea is that there's very few people out there and they're getting these basic training on how to be a clinician. And a lot of the way we approach a lot of these neurological issues is we approach them as an adult, right? We think about, okay, as an adult, we would want to get somebody up and walk, and we think like, okay, a kid can't read and they're dyslexic. So what do? Well, make them read more. To an adult, that kind of makes sense. But really, when you think about it from a developmental perspective, it makes no sense. You're trying to get the child to use an area of their brain that hasn't even grown yet. But you're going to force them to try to use it even when it's not there. It's like saying, I'm going to force you to use your right arm even though you don't have it, right? So do this right arm exercise every day. And you're sitting there like, I don't have an arm. They're like, well, do the exercise. And if you do the exercise enough, your arm will grow. That's not the way it works, right? It's a top-down approach that we use to almost all of these developmental issues. So we're basically saying, well, use your brain and use your reason, and let's modify your behavior, and let's sit down in front of a computer and try to make you concentrate, or let's make you read books. And
if you just try harder.
Yeah, just try harder. Instead of saying, no, the foundation hasn't been built yet. So let's go back to that and then build it back up. And then we can add the more high level, cognitive based stuff, and then it'll work.
One of the things that we talked about the other day that I just haven't studied much of that I want to study more on. So I'm going to pick your brain on it a little bit. Can you tell me a little bit about how vision affects the brain and how the brain affects vision, and just speak to that for a couple of minutes?
Sure. Well, again, I look at everything from a developmental perspective. So when you look at the development, obviously the three systems that the brain and the nervous system is really built on is really the postural motor system, big muscles, especially along the spine, the inner ear, the vestibular system, and then the oculomotor visual system. So those three systems really form the basis. And those three systems, if you look at them, they're bilateral, right? So they're the only systems really that, they're on both sides of the body equally. We have two eyes, we have two ears, we have two sides of our spine and our posture. And then they end up being the foundation of the brain, which has two sides. So that it's all in this alignment. And vision, children don't really see clearly until they're really about 6 months of age. When they're born first, obviously they don't see a lot in the womb, but then when they're first born, they only really have more peripheral vision. They can see the outline, which is partly, during that period of time in the womb, in the first 2 to 3 years of life, the right brain is forming. So the right brain visually will always be more specific and better at looking at peripheral vision, at movement, motion detection, and at looking at the big picture. So the right brain just kind of gets the outline of things. It doesn't look at detail. Later on, after 3, when the left brain starts kicking in, then the visual system and different receptors called parvocellular receptors, as opposed to the initial magnocellular receptors, which have a large receptive field. So that's why, again, the receptors that are forming, the stimulus that's available, and the side of the brain that's developing, well, this is how it dictates and this is how it creates one side of the brain being a little bit better at certain things than the other. And then the parvocellular receptors, which is really more in the central field of vision, develop after 3 years, primarily 2.5. And that goes, more to the left brain. And the left brain is all about detail. It's about very clear vision and color vision. And, this shapes the way the occipital lobe on the left is different than the right. But obviously the idea is that we need to blend both of those together. So it's always about using the whole brain, but the right side develops better for certain things and the left brain becomes better at other things. The whole brain can become anything. But the fact that the brain becomes asymmetric and lateralized is absolutely true. It's crazy. Sometimes you read on the internet, there's a person wrote an article in Psychology Today several years ago, and the title of it was that the right and left brain thing is a myth. And when I read that, I was like, where's that coming from? Because that's completely wrong based on what we know with, decades of research. And, it turns out that he really was in the article, he talks about how the right brain and left brain are different and asymmetric. But he talks about how he didn't believe the idea of a right brain or left brain kind of personality type or style was right, because there was this article that came out in the University of Utah that kind of supposedly, showed that it wasn't true. Turns out, that article is not accurate, and the whole idea is wrong. But the idea that the right brain and the left brain, work and can become anything, but ultimately they become more specialized, and this gives us great advantage. But ultimately we need to blend them together. So, the left field of vision and the right side of vision, we get, motion detection, big picture, peripheral vision. From the right, we get the left, we get detailed, very clear central vision. We get more, looking at the colors, and we merge them together, and that's how we get appropriate visual processing. So it's a very, very important foundational system. If there's a lazy eye, if there's an imbalance, and it starts also with the oculomotor system. So the muscles are really what develop first, and then we develop a reflex called the optokinetic reflex, which, remember I showed you it the other day, where you look at, let's say, moving lines or anything moving, and the eye jumps back and forth or up and down. And that's a basic reflex that eye movements and vision are built on. And again, that has to develop appropriately. And if it doesn't, then, we may get problem where we have imbalances in eye muscles or a lazy eye, or, we can't really follow or track appropriately. And then this obviously affects the visual acquisition and, how we're able to merge our images together to form 3D vision in the brain.
So cool. It's been really interesting watching Remy's vision change as he gets older. He still does the side eye, so I'm excited to work with that a little bit more.
Now you kind of understand why he does the side eye, right? Because he never really completed developing his right brain. And so the right brain sees out of the side of the eye. So he kind of turns his head to kind of favor the side, which helps him engage more that right brain system, and then eventually, you look at things straight on with our macula, but you can kind of understand why autistic kids and kids like Remy will look at the side of their eye. What is that all about? Well, it's all about you're actually using either the right brain or the left brain more. You're favoring one side or the other.
Very cool. All right. Well, I know you've got a lot going on. You're going traveling.
Yes.
So I'm super grateful that you took the time to talk with me. Is there anything else that you feel like other parents or other practitioners should know, or can they reach you?
Yeah, I think, there's a lot of different things. My website is really very active. So there's a lot of stuff on there. I have a lot of different programs, educational programs for professionals, for parents. I do, coaching programs to help people bring a lot of this information out to the world, and also bring it into their families and into their lives. I have a group, coaching and therapy programs that I do with parents around the world if they want to really incorporate a lot of my work into their home. All of this can be found on my website, drrobertmelillo.com. I also just created an online course for adults with ADHD and different types of brain imbalances that's completely online, that they can also go to, where they can assess themselves, find out about their own brain, and then basically follow this course and see if they have primitive reflexes. And then I give them specific exercises and activities. And a lot of the information there is something that they can do at home on their own. So I think, if somebody's really struggling, and adults obviously can't always it's harder to get to an office or something. This is something that people can do on their own. And then obviously my books are also available through there, and I have vitamins and supplements that I created. So anything that's out there really on my website. I'm also pretty active on my Instagram. And what I try to do is, a lot of people ask me about what do these primitive reflexes look like, or what does it look like? How do I assess it in my child or myself? And so I'm always putting on little videos on my Instagram So at Dr. Rob Melillo is my Instagram, and it's connected to my professional Facebook page as well. So I'm always putting a lot of educational videos out there. I do have, like I said, my professional course. I'm starting to teach it live down at Life University in Atlanta in September. And I'm also going to be teaching it in Bulgaria for European and people around the world starting in September as well. So, all of that information is on my website. People can go to that. People can check it out if they want to do that. And they can reach out to me. I usually try to answer questions, especially on Instagram. But, I try to just get this information out in any way possible to people. And, I'm just anxious to talk to anybody that wants to know more.
Well, awesome. It really, to me, again, getting this education out there is so huge. Not only have you developed a program that seems to really, really work and look at the whole brain and really help support neurology and development, the fact that you're doing so much advocacy and education around it really is amazing. I've met a lot of doctors who are brilliant, but who sort of keep their stuff in their practice. And, to me, the more we can get this out there, the more we can empower and educate parents and families, the better we all are. So thank you so much for that. And thank you so much for your time. I will let you get back to your family before you go travel. Thank you again. I hope you have an awesome day.
Great. Yeah.
Thank you for listening to the Radical Remedy Podcast. The Radical Remedy Podcast is for general informational purposes only and does not constitute the practice of medicine, nursing, or other professional healthcare services, including the giving of medical advice, and no doctor/patient relationship is formed. The use of information on this podcast or materials linked from this podcast is at the user's own risk. The content of this podcast is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Users should not disregard or delay in obtaining medical advice for any medical condition they may have and should seek the assistance of their healthcare professionals for any such conditions.